We're going to start this video on stoichiometry by balancing this complete combustion reaction for candle wax. Remember, a complete combustion reaction has some type of organic fuel reacting with oxygen gas to form carbon dioxide, water, and energy. So if we start by balancing this, C36H74 definitely looks the most complicated. I'm going to start by putting a 1 there. And then you will see that we need 36 carbons, so we need 36 CO2s, and we need 74 hydrogens, so we'll need 37 waters. That gives us 72 oxygens here for CO2, and then 37 more, so 109 oxygens on the product side. So we need 109 oxygens on the reactant side. Therefore, we have 54 and a half O2 molecules. On the reactant side, this gives us a fraction. To get whole numbers, we simply need to multiply all the coefficients by 2. Either one of these will be an acceptable way to balance this reaction. Stoichiometry is simply taking the mole concept that we've been working with and applying it to balanced chemical reactions. We should be able to start with any substance in a chemical reaction and use the mole ratio in the balanced chemical reaction to find out how much of a different substance we need to use or was produced in that reaction. So let's look at an example using our balanced candle wax reaction. If we have 58.7 grams of candle wax, how many grams of carbon dioxide would be added to the atmosphere if it was burned? So this is going to be a calculation when we set up a dimensional analysis. And for a stoichiometry problem, we always want to follow a specific game plan. If you follow these steps, you will win every stoichiometry problem that you do. If you do not follow these steps, then you will lose and become very frustrated. The 4 steps are to start with what's given, convert that to moles, then use the mole ratio from the balanced chemical equation. That is the most skipped step by students. Finally, we are going to convert to the unit that we are looking for. So we're going to be referencing this balanced equation, and we're going to go through the game plan. We're going to start with what's given, 58.7 grams of wax. We are going to convert that to moles. You convert a mass to moles by using the formula mass. The formula mass for wax is 506 grams per mole. This will allow us to cancel the grams of wax. Step 3 then is to use the mole ratio from the balanced chemical equation. Okay, in this case we have 1 mole of wax. And how does the mole of wax relate to the moles of CO2? Look at the mole ratio. 1 mole of wax will give you 36 moles of CO2. This will allow us to cancel the moles of wax, and now we can convert to what we are looking for. The question asks for how many grams of carbon dioxide would be released to the atmosphere. So we're just a step away. To go from moles to grams, we're going to use the formula mass of CO2. 1 mole of CO2 is 44 grams of CO2. This conversion will allow us to cancel the moles of CO2. When we calculate this out and have 3 sig figs, we will get 184 grams of CO2 released into the atmosphere. Follow the game plan and you will win. We're going to look at some more problems. And for that, we're going to use this reaction for the complete combustion of acetylene. If you balance this reaction, you will get 1, 2, 1, 1. Let's look at an example. All right, how many molecules of acetylene are produced from 587 moles of water? So we're trying to go from moles of water to molecules of acetylene. If we follow the game plan, we will win. So remember, we're going to do dimensional analysis. We're going to start with what's given. In this case, 587 moles. The second step is to convert to moles. Well, lucky us. We're already in moles. We don't need to do step 2. The next step is to use the mole ratio from the balanced chemical equation. So the balanced chemical equation was 1, 2, 1, 1. We need the mole ratio of water to acetylene gas, which you can see 2 moles of water will give you 1 mole of acetylene gas, C2H2. This allows us to cancel the moles of water. The fourth step in our game plan is to convert to what we are looking for. We are looking for molecules of acetylene. So how do we get from moles to molecules? We use Avogadro's number. We know 1 mole of C2H2 will give us 6.02 times 10 to the 23rd molecules of C2H2. This allows us to cancel the moles, and we are left with molecules. When we multiply this and divide this through, and we round it to 3 sig figs, we will get 1.77 times 10 to the second molecules of C2H2. Now it is your turn to try out a stoichiometry problem. You need to figure out how many moles of steam that are produced from 6.24 moles of oxygen gas. If you follow the game plan, you will win. If you don't follow the game plan, you will surely suffer. Try to solve this problem on your own. Pause the video now and get her done. The last stoichiometry problem that we will do involves one of my favorite demos, which is gummy bears in hell. A gummy bear is basically just sugar. We're going to react it with molten potassium chlorate, and the products are carbon dioxide, water, and potassium chloride, and a lot of energy, as you can see. The balanced reaction is as such. We are going to solve the following stoichiometry problem. How many liters of carbon dioxide would be collected at STP if 500 gummy bears were burned? So we're going to set up our dimensional analysis, and we're going to follow the game plan. We start with what's given, which is 500 bears. We have a conversion because 1 bear is 2.08 grams of sugar. This will allow the bears to cancel. Now we can get from grams of sugar to moles of sugar using the formula mass of sugar, 342 grams per mole. That will allow our grams to cancel. Now we can use the mole ratio from the balanced equation. 1 mole of sugar will give us 12 moles of carbon dioxide gas. We are now in moles of carbon dioxide gas, but the problem asks for liters of gas at STP. So we can make use of our friendly little conversion. 1 mole of CO2 is 22.4 liters of gas at STP. We do the multiplication and division. We should get 817 liters of carbon dioxide.